Well, hello everyone. Welcome to Mr. MathWell video. This is Math 9, Chapter 9 review video. So I'm going to go through the whole chapter, going to talk about probability and statistics in this chapter. So hopefully you've did the homework and hopefully you've been paying attention in class and you know a little bit about this already. It's going to be a quick review for the chapter. So in this chapter we're learning about probability and statistics, as I mentioned. So what is the role of probability in society? Like, how is that applicable to our real life? And we're going to address problems with data collection. We're going to talk about the difference between a population and a sample. And we're also going to plan to collect, display, and analyze data in some sort of survey or something. Your teacher may be asking you to do something like that. So we'll go over what you should be looking at there. Here's some key words over here. And data, census, sample, valid, conclusions, and rubric. And I'll go over a little bit of each of those here in this video. A quick note here. Look at this. Why is it important? People make decisions based on data. So we have to understand what the data really mean. And we have to be confident that the data are accurate. Now, I just wrote this on the side because sometimes I even make the mistake. Data is plural. That means there are many items. So data is a multiple item topic there, and so it's data are accurate. A datum, D-A-T-U-M, would be the singular piece of data. Okay, so that's why that sounds a bit funny, I think, in a sentence. So I outline that for my students too. All right, 9.1, probability in society. So here's a picture of Haley. She's a basketball player, and it says Haley made 44 out of 50 basketball shots that she attempted. What is the probability that Haley will sink the next shot? So when we think about something like that, obviously we go on our past record, right? So for Haley, she's a pretty good shooter, right? 44 out of 50, that's 88%. So that's a pretty good free throw shooter. That means in the past, she's hit 88 out of 100 shots, or 44 out of 50 shots, and that's a pretty high percentage. So we would guess that she would probably make the next shot, right? So that's how we use probability. If another basketball player only made 20 shots out of the 50, well, that person would be probably less likely to sink the next shot. You know how that works? Okay, so we use probability every day. Now here's another example I thought was interesting because this helps us to learn about bias and about how we interpret data. So this little example here says John wants to learn how to snowboard, but he doesn't want to take lessons. His mother insists that he does take lessons. John and his mother found this little clipping in the newspaper which said 68% of snowboarding injuries occur during beginner lessons. So how do you think that each of them will use that piece of data, that probability, and to argue for their point? Well, it can be argued both ways. So mom says, see, look, the beginners have a lot of injuries. You should take lessons. Besides, the injuries in beginner lessons are probably minor because of the controlled circumstances. So you see how mom could kind of say, listen, beginners are prone to accident. You should take lessons. And of course, John might say, oh, I'd be better off avoiding lessons because most of the injuries happen there. Look at 68% is 68 out of every 100 injuries. So you can see how they would both use the data for their own sort of end goal. Again, probability is, I have this highlighted over here, probability is the likelihood of an event happening, or the likelihood that an event will occur. So when we talk about probability, that's what we mean. If the rain forecast is 60% rain, well, that means that there's a little bit more than half a chance, right? 60% chance that it will rain given those conditions. When we take a look at data and probability and things like that, there are always assumptions that we make, okay? Assumptions are those things that you assume to be true, or those things that you believe are true and that will happen kind of in the background, assumptions. So here are some assumptions in this particular example. The assumption is that John will experience the same injury probability as this advertisement, right? Because both of them are talking about this and applying that directly to John. That's an assumption. Maybe he's naturally really good at snowboarding and that he has a far less chance of getting injured as a beginner. Who knows? They're also assuming that without taking lessons, John only has a 32% chance of injury, right? That's an assumption. And another assumption might be lessons always prevent future injuries. Now there would be many more, maybe you can think of some more, but those are just a few that I wrote down. So as we mentioned, decisions based on probabilities may be a combination of two different types of probabilities, theoretical and experimental probability, and also includes some subjective judgment. Okay, so there's some big words there. We'll go over that in a little bit. Theoretical probability. Okay, that's based on the nature of the situation. So, for example, if you flip a coin, and the side with the head on it is heads, and the other side is tails, then by nature there's only two options. So it's a 50-50 chance, right? It could be heads or tails. But in reality, of course, that may not be the case. If you flip the coin 10 times, the experimental probability, it may come out different than 5 and 5, right? It may come out 7 and 3, or 6 and 4, or 1 and 9, or something like that. So those are the two types of probability. Theoretical, based on the nature of the situation. Okay, someone's going to have a child. Okay, it's going to be a boy or a girl, right? It's only two chances, so it's 50-50. Well, is it 50-50, right? What is subjective? Subjective means it's based on personal beliefs or feelings, not only on data alone. So objective would be based on the numbers or the data alone, with very little personal beliefs or feelings involved. Okay, that's objective. Subjective is like what I feel about the situation. Objective would be based on data alone. And so in this case, of course, it's kind of, both of them are looking at that fairly subjectively. John really wants to snowboard without lessons. So his feelings are that, hey, Mom, listen, lots of injuries. I don't want to do that. Right? You see how that works? All right, that's 9.1. 9.2 is potential problems with collecting data. Okay. So, I was going to do this. You see this right here? I was at the end of each section. I was going to press this.
That was easy.
There you go. Just reminds us how easy that was. Maybe you like that. Maybe you don't.
That was easy.
Thank you. 9.2, potential problems. Okay, so there are things that we need to pay attention to when we are collecting data or when we're using data, but more importantly when we're collecting data. So these are pretty important things that I'm going to talk about. So the example here is, suppose your friend asks you, who do you think will win the Western Hockey League playoffs? Who's going to be the champions? Well, what might affect your answer to this question? Obviously, you may have some bias. This is the first one, bias. And that in the asking of the question is really what we're getting at here. An example would be if someone asks a question that has bias in the question. They would say, "Don't you think the price of a movie ticket is too high?" Okay. If someone asks you a question like that, you know right away that they think the movie tickets are too high, right? Just by the way they ask that. So you have to word your question in a way that there's no bias. Okay. Who do you think will win the Western Hockey League? That's a pretty good question, because it's not like, the question might be, don't you think that the Brandon Wheat Kings are going to win this year? Right? That's kind of like loaded with personal bias, that question. Okay. What else? Use of language. Okay, if you're wording the question in such a way that you're leading the person to an answer unfairly, that's use of language. So, don't you think the price of a movie is too high? A better question would be, do you think the price of a movie ticket is high, low, or fair? That's wording it in a way that you're not putting any pressure on anybody. Okay, timing. This is a good one. If you're going to ask someone if they'd rather go to McDonald's or the library, and it's like lunchtime and they're really hungry, you're going to get a lot of people say, you know what? Oh, my stomach is growling. Let's go to McDonald's. But if it's just before a test, they might say, well, let's go study, So the timing of your question, you have to be careful when you're asking the question. Spread that over lots of different times, maybe that might help. Privacy, okay, you don't want to ask people questions that are deeply personal, or it may cause them to not tell you the truth if it's too personal. Cultural sensitivity, okay, so if people from different cultures may have different views on things, or the question may not be even applicable to their religion or their culture, so you have to be careful about that. Ethics, okay, is this a question or is this a survey, or is this something that is proper, for people to be asking, that sort of thing. Cost, okay, will the cost be high of collecting data? or will the time required to collect the data, will that be extensive? So you kind of have to take all these things into consideration when you're collecting data and how you're asking your survey questions and things like that. So that's generally 9.2. I don't have any examples or too much of that, but the potential problems with collecting data. Okay, so 9.3 is, I believe this, oh no, there's 9.42, but 9.3 says use samples or populations. Okay, so in this section, we learned how to differentiate the difference between a population and a sample. A population is the entire group, right? And if you're asking the entire group a question, that's called a census, okay, a census. And if you're asking just a smaller portion of the entire group, that small portion is called a sample, okay? And so you would ask, take a survey of the sample of people. Now, the reason why you take a sample, obviously, is because, if there's like 1 million people that you're trying to find out what they think about a certain subject, you can't ask 1 million people the question, right? You can't do it 1 million times. You would have some kind of smaller group that would hopefully represent the big group very well. So you want to make sure that the sample is representative of the population, and that will give you a valid conclusion, a conclusion that is fair and reasonable and trustworthy. That's what valid means. So, for example, if you wanted to know what the favorite movie of your classmates would be, you would take a census. You would ask everybody. That's pretty easy to do, probably, right, if you're in a smaller school. If you wanted to know what the favorite movie of all grade 9 students in North America was, well, obviously, you couldn't ask them all. It would not be...
That was easy.
No, it wouldn't be. So you would take a smaller group of those, right? You take a sample, and you would find out, you'd ask a lot of people still, but you couldn't ask everybody, so it's a sample. All right, how do you select a sample? That's what 9.4 was about. So there are different types of sampling. We'll go over them real quick here. One is a simple random sample. This is the easiest one. You just randomly pick people. There's no reason why you're picking them. It's just like out of a hat almost, like Jimmy, Sally, Susan, whatever. Random, okay? Self-selecting sampling is when people that are interested, that will volunteer for your survey, they are the ones that will participate. So it's you rely on the people themselves to decide who takes part. So if you don't want to ask 100 people that don't care, you might want to say, hey, listen, whoever cares, if you have an opinion about this, why don't you let me know what you think? That's a self-selected sample. A systematic or interval sampling would be like, let's say you pick every 3rd person or something, right? Or every 10th person. Like at a grocery store or something, they might give a survey to every 20 people or something. If you're assembling products, every 20th product or every 100th product or whatever you choose, that one you're going to grab it and you're going to pick that and you're going to give it a test. Interestingly enough, I didn't highlight this, but destructive sampling, okay, that's in italics here. And if you take something and you test it for its quality and you can't use it again, that's called a destructive sample, okay? So if you take a little toy that you on an assembly line and you like hammer it until it's squished and to oblivion, then you can't use it again. That's a destructive sample. You say, oh, it took me 10 hammers to wreck this thing. It's pretty good. I don't know why I chose that example. Convenience sampling. Okay, so members of the population who are convenient to include are selected. There's some problems with this, isn't there? You might not get everybody if you just ask your friends, but that's a convenient sampling. And then, that may be valid. You may have a lot of friends from a lot of different walks of life or that have a lot of different opinions, but that's a convenience sampling. Cluster sampling would be, every member of some randomly chosen group. So for example, let's say you're going to ask high school students, you're going to pick grade 9 students, and you're going to pick one form of the grade 9 students, you're going to ask all of them. So that's just a cluster. You take a big group of people, ask them all what they think, not necessarily caring about, they have to be in different grades and different genders and different, whatever. Finally, stratified random sampling, that sounds pretty complicated, but that's basically you're taking each group and you're randomly choosing the same number from each group. So again, if you're asking high school students a certain question, you might say, okay, I'm going to ask 5 people from each grade, just so you get a little bit of opinion from each grade. And it doesn't really matter if the grade has a different number of students. You're not really paying attention to that. You're just going to do 5 from each. Okay, last section here, designing a project plan. So if you have to come up with a survey question or a question that you are going to find out information about, there are some steps and some things that you need to consider to design. First one, prepare a question. Remember all of those things you want to keep in mind: avoiding bias, be culturally sensitive, watch the timing and all that sort of stuff when you ask the question. Choose a sample would be the second thing. Are you going to do a population? Are you going to do a census, ask everyone, or are you going to choose a sample? What kind of sample would be best to give you a valid conclusion? The third step would be to actually collect the data. So you would ask people, phone people, message people, however you're going to do that, get people to comment on your Instagram, whatever, collect the data. 4, analyze and display the data. So you're going to take all of those answers and you're going to do something with them. You're going to evaluate them. You're going to analyze them and find out what the answer is to the question that you're asking about. And then you're going to display your data somehow. You're going to put it into a graph, you're going to make a video, you're going to do something like that, and you're going to show everyone what you found out. Finally, the fifth one is design a rubric. Now this is a funny word that you may not be familiar with, but your teachers probably use rubrics a lot and you've probably seen them. They help you evaluate your project by basically giving you levels of achievement, right? So you've seen these before. You want to take a close look at your question, your sampling, your data collection, and all this. These are the sort of different categories. And then you want to identify what would be an excellent question. What are the characteristics of an excellent question? And you would come up with the evaluation of that. So, for example, I just jotted down here a question. My question was free from bias and extremely clear. Question was proofread by another classmate. Okay, that would be a level 4, top level. Okay, you give yourself a top level if you got that. Maybe the lowest level would be question was biased, confusing, and not proofread. You get the picture? So by you filling out all of these spots here, you're actually really critically evaluating sort of what's good and what's bad, and you can judge how you did on your project. Okay, and of course these are the problems that you have to consider. We went over those earlier. Okay, so I think that's the end to my review video. I hope you found that helpful, and I hope you do really well in your Chapter 9 exam or your evaluation coming up. And yeah, check out other videos for Math 9, Mr. MathWell.